Hi, Dr. Shuri. So, basically, for this lab, we were looking for if the resistance of a wire depends on the material of the wire, and also if the resistance of the wire depends on its cross-sectional area, and if so, how. And we were given this table, and we were expected to choose a set of data in order to prove those questions, or not prove, but like answer the questions, but also prove. So for the first activity, we were looking at the resistance for the different materials. And so for the independent variable, I said that it was the material of the wire. The dependent variable was the resistance, and the control variable was the current, the wire diameter, and the wire length. So what I chose specifically was the wire length. I chose was the 4 centimeters. The current was the same throughout the whole thing. It says that it was 0.50, and the diameter I chose was 0.10 because aluminum, copper, one of the brasses, nichrome, and stainless steel all had the same diameter. And like I said, the current was the same. The current was the same. And then also I use 4 for all the wire lengths. And so I basically used the equation that we used from the previous lab, where R is equal V over I. And I took it for each of the voltages. So I took it, I don't know, it's probably showing backwards, but I took it for each of like the different voltages that was provided by the table for that link for 4. And then I had calculated what the resistance would have been. And obviously you could tell that the wire of the material does affect the resistance, because all of the resistance were different, because they had different voltages for each of the material. And then when I further looked at my notes from a lecture, I seen that basically that it does depend on the material of it, and that was obvious by an equation that was provided, where it was R equals the resistivity, so rho L over A, which could have also used that equation to find resistance, but I just used the one that we used in the previous activity. And so basically what I concluded was that so from looking at that equation, that we could have seen that obviously that the resistivity does affect resistance, because it's in the equation and it's being multiplied by it. So of course it will be directly proportional to that, which I could also see from my results, because as I saw that as the resistivity, because I did also at the bottom, I did actually look up what each of the materials, like all the different resistivities of the materials, and I saw that as the resistivity increased, also the resistance increased. Even though I didn't use that equation and I used the other equation, I still seen that that also had a relationship. So for the conclusion, I said that the resistance in a wire depends on the material of the wire, because different materials have different resistivities. And just to be clear, that resistivity is the ability of the material to allow electrons to move, which is also dependent on temperature and electronic structure. And additionally, when observing the calculated values for resistance of the substances, it can be concluded that resistance is directly proportional to the resistivity of the materials by which the substance is made. So basically, just summing up everything that I had just told you, even though that's probably sound like in a better way, but so basically all I did was I used the past equation to calculate the resistance, and I also looked back in my notes from lecture to see that they had another equation which included a resistivity in it, and I looked up all the resistivity values, and I basically looked at the resistance I calculated and the resistivity values, and I seen that basically the resistivity was different for different materials, and also voltage was different for different materials, because they had different conductivities. Like some substances have better conductivity than other substances, so of course that will affect the resistance. It would affect the resistance, and that's how we seen that it had different resistance values. And so then for the next activity, we had to see the cross-sectional area, and for this one we had to specifically say if it was inversely or directly proportional. So for the independent variable, I said that was cross-sectional area of the wire. Dependent, I said that was resistance. And for the control variable, I said current, wire length, wire material, and resistivity, because I actually did end up using that equation, the one I said before, where it was the rho L over A, but they didn't like flat out give us area, so I knew that area was pi r squared, and so we had diameter, so I took pi diameter square over 4 and then put that into the actual equation. So I got r equals 4 pi L over pi diameter squared, and I used that to find this resistivity. I mean, not resistivity, resistance. I'm sorry. I used that to find the resistance. So the things I kept constant was I kept current, which was 0.50, wire length, which I changed it to the 8 centimeters. I used the wire material brass, and the resistivity I kept it the same. The one that I looked up that I showed in the previous one was 0.6 times 10 to negative 7, because it said 0.6 times 10 to negative 7 through 0.9 times 10 to negative 7. So I just went with the smallest one, 0.6. And yeah, so from the table, I just used that one because brass, it was all the same material. It had different diameters, but the lengths were kept constant. So I used all the same length, and the current was constant and stuff. So basically I just used that equation and I calculated. It's kind of like brought over. Well, I don't know if I'm pointing at the right thing. Oh wait, no, that was the other page. This one. So yeah, I calculated all of them and got my different resistivities. I mean, you'll see better like once I send a picture on the email, but I calculated all different resistivities, and basically from that I did see that as the diameter increase, which does depend on the area, because like I said, it was pi d squared over 4, that it does affect that the cross-sectional area, which includes in the diameter, it does affect resistance, because as a diameter increase, which like I said affects area, the resistance decreases. And so basically from that I concluded that the resistance is inversely proportional to the cross-sectional area, because like I said, as the area increase, the resistance decrease. And I also went further into explanation, because the reason being that so resistance, it occurs by electrons colliding, and so if we increase the cross-sectional area, there will be basically more space in between the electrons or whatever charged particles, and so it'll go from this, to being bigger, so it'll be less collisions, and so of course that would decrease the resistance. So yeah, so as the area increased, the number of collisions decrease, which is why the resistance decreased. And so basically we've seen that both the cross-sectional area does affect resistance, and the material does depend. Well, resistance of the wire does depend on the material, and that was basically concluded from the results. It really wasn't that bad. It really helped having a table and stuff like that. And I think it went pretty well. So I hope you enjoyed the video. Thank you for watching, Dr. Chivalry. Have a great day.